What if I told you the most terrifying objects in the universe don't live forever? Not even black holes. Not the devourers of stars. Not the monsters that bend space, swallow light, and erase everything that dares to come too close. Even they will die. And when they do, the universe will witness something it has never seen before. A final glow in a place where light should not exist. A quiet collapse of time itself. A last explosion. Carrying the memory of everything that has ever fallen into darkness. Tonight, we are not just talking about black holes. We are traveling to the very end of time, to the moment when the last star has faded, when the last atom has drifted apart, and only one thing remains: a single black hole, slowly, silently, coming to an end. What happens inside it, in its final moments? Does everything it consumed disappear forever? Or does the universe, in its strangest way, remember? This is not just a story about space. It is a story about existence itself, about endings, and about the quiet possibility that even the end is not truly the end. So dim the lights, take a breath, and let your mind drift into the deepest darkness the universe has ever known. Before we begin, I have a small favor to ask. If you enjoy deep, mysterious journeys like this, please take a moment to gently tap the like button and subscribe to the channel. This channel is still in its early stages, and every single like, every subscription, every comment truly helps it grow. It means more than you might think. And if you've already supported the channel, thank you. Sincerely. Now, let's begin our journey to the end of the black holes and beyond. Black holes do not last forever. At the far edge of time, even they are only flickering candles, trembling quietly before they fade into the vastness of nothing. Imagine a universe where every light has gone out. Not dimmed, not hidden, gone. No stars burn, no galaxies swirl, no planets drift in gentle orbit. Even the faint glow of dying suns has long since vanished. What remains is a silence so complete, it feels almost like a presence of its own, pressing softly against the fabric of existence. In this deep and endless dark, there are no colors, no warmth, no familiar shapes. Space itself stretches on, cold and empty, like an infinite ocean without waves. And yet, something still lingers. Not life, not matter as we know it, but something heavier, older, hungrier. Black holes. They are the last survivors, the final monuments of a universe that once blazed with unimaginable brilliance, where galaxies once collided in slow, majestic dances. Now only these dark giants remain, scattered across the void like forgotten ruins. Each one carries within it the memory of everything it has ever consumed: stars, planets, light itself, all compressed into a silence so dense it cannot speak. If you could drift close to one, just close enough to feel its presence, you wouldn't see it in the usual sense. There is no surface, no glow, only a perfect darkness, a circle cut out of reality where even light has surrendered. Around it, space bends. Not dramatically, not violently, but subtly, like a sheet pulled ever so gently inward. The stars that once framed it are gone now, but the distortion remains, a quiet reminder of its power. These are not merely objects. They are the last structures holding shape in a universe that has otherwise dissolved into entropy. Time, too, has changed. Here, in the age of cosmic loneliness, time no longer feels like a flowing river. It feels thin, stretched, almost meaningless. Without stars to mark cycles, without motion to measure change, time drifts quietly, unnoticed. It no longer rushes forward. It simply exists, like a long exhale that never quite ends. And in that endless duration, the black holes remain, watching, waiting. But even now, something is happening. Something incredibly slow. So slow that for most of cosmic history, it went completely unnoticed. Black holes are not eternal. They are not perfectly sealed. They are leaking. At the edge of each black hole lies a boundary known as the event horizon, the point beyond which nothing can return. It has long been thought of as a one-way door, a perfect prison. But reality, it turns out, is never that simple. In the strange world of quantum physics, even empty space is not truly empty. It trembles with activity, tiny fluctuations where pairs of particles appear and vanish in an instant. They are called virtual particles, and they exist only briefly, like whispers that fade before they can be heard. Except, near a black hole, something unusual happens. These fleeting pairs are torn apart. One particle falls inward, pulled past the event horizon, lost forever. The other escapes, and in escaping, it carries something with it: energy. From the outside, it appears as though the black hole is emitting radiation, a faint, almost imperceptible glow. Not bright like a star, not even visible to the eye, but real. This is what we call Hawking radiation, a slow evaporation, a quiet undoing. Every escaping particle takes a tiny piece of the black hole's mass with it. Not much, not enough to notice at first, but over unimaginable stretches of time, it adds up. The black hole begins to shrink. Picture it like a candle in a windless room. At first, the flame is steady, calm, almost eternal, but slowly, imperceptibly, the wax melts. The flame flickers just a little weaker. The change is so subtle, you wouldn't notice unless you waited and waited and waited. Black holes fade like that. Not with drama, not with sound, but with patience. In this era of the universe, there is nothing left to feed them. No gas clouds drifting too close, no stars wandering into their grasp, no collisions, no mergers, no fresh matter to sustain their immense gravity. They are alone, and because they are alone, they begin to starve. The largest black holes, those that once sat at the centers of galaxies, take the longest to fade. Their mass is enormous, their presence still commanding, even in a universe stripped of structure. But even they are not immune. Given enough time, trillions upon trillions upon trillions of years, they too will begin to diminish. And here's where it becomes even stranger. The smaller a black hole becomes, the faster it evaporates. At first, the process is slow beyond comprehension. But as mass decreases, the rate of radiation increases. It's as if the black hole, sensing its own end, begins to unravel more quickly. A quiet acceleration, a subtle urgency. What was once stable becomes unstable. What was once eternal reveals its fragility. If you could watch this process unfold, not over seconds or years, but over cosmic timescales, you would see something almost poetic. A giant, once capable of devouring entire stars, slowly giving itself back to the universe, one particle at a time. Returning everything it ever took, though not in any recognizable form. And still, the universe remains silent. There are no observers left, no civilizations to measure the change, no eyes to witness the fading, only the black holes and the darkness between them. But deep within this stillness, a question lingers. What does it mean for something that once defined the boundaries of reality to begin disappearing? What happens to everything it held inside? The stars it consumed, the matter it crushed, the information it seemed to erase. Does it all simply vanish? Or is it waiting for something else? For now, the black holes continue their slow decay, unaware, or perhaps indifferent to the fate that awaits them. Their event horizons remain vast, though shrinking. Their gravity still warps space, though weakening. Their silence persists, though something beneath it is changing. A countdown has begun, not measured in seconds, not even in centuries, but in the quiet ticking of quantum processes at the edge of existence. And somewhere, in the deep mathematics of reality, the ending is already written, a future where even these last giants will flicker and go out. But before that final moment arrives, before the last breath of gravity fades into nothingness, something extraordinary begins to unfold within and around them. Something that challenges everything we think we know about space, time, and the nature of existence itself. Because as a black hole shrinks, its boundaries tighten. Its horizon contracts, and whatever lies within begins to feel it. The prison walls are closing in, and the universe, though silent, is not finished telling its story. As the invisible boundaries begin to tighten, something subtle yet profound starts to change. At first, the black hole does not appear any different. From the outside, it is still a perfect void, still silent, still absolute. But beneath that stillness, a process has begun that cannot be stopped. The evaporation continues, not as a dramatic burst, not yet, but as a steady, patient release, like breath slipping unnoticed into the cold. Each moment, particles escape. Each moment, the black hole loses a little more of itself. This is not destruction in the way we usually imagine it. There is no collapse, no explosion, no sound. Only a gradual thinning, as if reality itself is being gently unraveled at the edges. Hawking radiation, so faint, so elusive, becomes the defining behavior of the black hole in this era. There is nothing else left for it to do, no matter to consume-trap, only to slowly give itself away. And yet, there is something almost paradoxical about this process. Black holes were once the ultimate absorbers. They devoured everything. Now, they are becoming emitters. A reversal, a quiet transformation. If you could measure the temperature of a black hole, something that once seemed impossible, you would find something unexpected. It is not cold, not in the way empty space is cold. It has a temperature, and that temperature rises as the black hole shrinks. At the beginning of its life, a massive black hole is incredibly cold, colder than the faint background glow that once filled the universe. But now, in this dark age where even that background has faded, the black hole becomes one of the few remaining sources of energy, a dim, ghostly warmth. And as it loses mass, that warmth increases. Slowly, then steadily, then noticeably. It is as if the black hole is heating up as it dies. This creates a strange and almost unsettling image, a thing defined by darkness, beginning to glow. Not with visible light, not yet, but with energy escaping into the void. A whisper of existence where there should be none. The smaller it becomes, the more intense this radiation grows. What once took billions of years to lose a fraction of its mass now begins to change more rapidly. Time, which once felt irrelevant here, begins to matter again. The process accelerates. Imagine holding a block of ice in your hand. At first, it melts slowly, almost imperceptibly. But as it gets smaller, the melting speeds up. The surface area changes. The structure weakens. Soon, it is no longer a solid block, but a fragile remnant dissolving quickly. Black holes behave in a strangely similar way. Except this is not ice. This is the fabric of space-time itself, unraveling. Each escaping particle carries away energy, but energy and mass are linked. So with every whisper of radiation, the black hole becomes lighter. And with less mass, its gravitational grip weakens, its horizon shrinks, its presence fades. But here is where the process becomes truly strange. The radiation is not random noise. It has structure, a spectrum, a pattern that suggests something deeper is happening beneath the surface. It is as if the black hole is not just losing energy, but telling a story written in particles, in fluctuations, in the faint echoes of quantum processes unfolding at the very edge of reality. And yet, we do not fully understand what that story says. Because this leads us to a profound mystery, one that has troubled physicists for decades. If a black hole evaporates completely, what happens to the information it contained? Everything that has ever fallen into it, every star, every atom, every fragment of light, should be encoded in some way within it. Information, according to the laws of physics, cannot simply disappear. It must be preserved, transformed perhaps, but not destroyed. And yet, Hawking radiation appears, random, thermal, featureless. It does not seem to carry detailed information about what fell in. So, where does it go? Is it lost forever? Erased from the universe? Or is it hidden in ways we do not yet understand? This question lingers like a shadow over the entire process. Because if information can truly vanish, then something fundamental about reality is broken. But if it cannot vanish, then black holes must be far stranger than we ever imagined. For now, the black hole continues its quiet decay, indifferent to the questions surrounding it. Its mass decreases, its temperature rises, its radiation intensifies. A slow transformation, becoming less of a void and more of a source. And with each passing stretch of cosmic time, the balance shifts, from absorption to emission, from silence to a faint, persistent whisper. There is something almost poetic about it, a structure that once consumed everything, now giving everything back. Not in the same form, not in any recognizable way, but still returning. And yet, this is only the beginning of the end. Because as the black hole shrinks further, the processes at its edge become more violent, more unstable, more unpredictable. The calm evaporation will not last forever. The closer it gets to its final moments, the more the rules begin to bend. The event horizon, once vast and untouchable, is no longer distant. It is closing in, tightening. And whatever lies just beyond it is beginning to feel the pressure. Something is happening at the boundary between existence and non-existence. Something that turns the quiet fading into something far more complex. Because near that shrinking edge, reality itself begins to flicker. Tiny fluctuations grow stronger. Virtual particles, once fleeting, now appear with greater intensity. The delicate balance that allowed the black hole to exist starts to destabilize. And in that instability, a new layer of the story begins to unfold. A story not just about loss, but about what was never meant to escape. Because at the edge of the black hole, in that thin and trembling boundary, something impossible continues to happen. pairs of particles are being created and torn apart again and again and again. And each time, the universe steals a little more from the darkness. A theft so subtle, it took an entire civilization to even notice. But now, in the final ages of time, that theft is becoming impossible to ignore. The boundary is no longer stable. The illusion of permanence is breaking, and the black hole, once the ultimate prison, is slowly losing its grip, as if the universe itself is reclaiming what was taken. One particle at a time, and with every escape, the ending draws closer. At the edge of the black hole, the quiet theft continues. It does not look like a theft. There are no hands, no motion you can see, no sound to mark the moment something is taken. And yet, again and again, something escapes. To understand this strange process, you have to let go of the idea that empty space is truly empty. Because it isn't. Even in the deepest vacuum, even in the coldest, darkest regions of the universe, space itself is alive with subtle activity. Tiny fluctuations ripple through it constantly, like invisible waves passing through an unseen ocean. Out of these fluctuations, pairs of particles briefly appear. They are born together, twins of energy, one with positive energy, one with negative. They exist for the briefest possible instant, so short that, under normal conditions, they vanish before anything can notice. They cancel each other out, as if they were never there at all. But near a black hole, the rules change. At the event horizon, the delicate boundary where escape becomes impossible, these pairs are no longer guaranteed to reunite. The gravitational pull is so extreme, so uneven across such a tiny distance, that it can separate them before they disappear. One particle is pulled inward, the other is flung outward. And in that moment, something extraordinary happens. The particle that escapes becomes real. No longer a temporary fluctuation, no longer a whisper, but a permanent part of the universe. It carries energy with it, and that energy must come from somewhere. From the outside, it appears as though the black hole has emitted the particle, as though it has lost a tiny piece of itself. But the deeper truth is stranger. The particle that falls inward does not simply disappear. It carries negative energy relative to the outside universe. And when it crosses the event horizon, it effectively subtracts from the black hole's total mass. A quiet subtraction. A subtle accounting. And so, with every pair that is torn apart, the black hole becomes slightly lighter. Not because something was taken from inside, but because something with negative energy was added to it. It is a process that feels almost like a loophole in reality, a delicate balancing act between quantum mechanics and gravity, a cosmic sleight of hand. Over immense spans of time, this process repeats endlessly. Particles appear, they separate. One escapes, one falls, again and again and again. Each event is small, insignificant on its own, but together they shape the fate of the black hole. Imagine standing beside an ocean, watching waves lap gently against the shore. Each wave seems harmless, barely noticeable, but over centuries those waves can reshape entire coastlines. Hawking radiation is like that, a slow erosion, a patient dismantling of something once thought indestructible. And as the black hole shrinks, the region where these quantum effects dominate becomes more intense, more active, more chaotic. The horizon is no longer just a boundary. It becomes a place of constant creation and destruction, a thin shell where reality flickers between existence and non-existence. If you could somehow observe it up close, not with eyes, but with a deeper sense, you would not see stillness. You would see turbulence. A restless dance of particles appearing and vanishing, being torn apart, escaping, falling inward. A storm made not of matter but of possibility. And yet, even this description falls short, because what is really happening at the event horizon challenges the very way we think about cause and effect. From one perspective, the particle escapes first, and the black hole loses energy as a result. From another, the black hole loses energy, allowing the particle to escape. Which comes first? Which causes which? The answer is not clear, and perhaps at this level of reality, the question itself no longer makes sense. Time and sequence begin to blur. What remains is only the outcome. The black hole is shrinking, and with each passing moment, if moments can still be said to pass, it becomes easier for these particles to escape. The gravitational grip weakens. The horizon contracts. The distance between inside and outside becomes less absolute. It is as if the barrier itself is thinning, and that raises a deeper question. If the boundary continues to shrink, what happens to everything trapped within it? All the matter, all the energy, all the information. Is it compressed forever into an unreachable point? Or does it somehow participate in this slow release? Some theories suggest that the information is encoded in the radiation itself, hidden within the subtle correlations between particles. Not obvious, not readable in any simple way, but present, preserved. Others suggest something even more radical, that the information is stored on the surface of the black hole, like a kind of hologram. That everything that has ever fallen in is somehow written onto the event horizon itself. And as the black hole evaporates, that information is gradually released, not destroyed, not lost, but transformed. If this is true, then the event horizon is not just a boundary. It is a record, a memory, a fragile archive of everything the black hole has ever touched. And as it shrinks, that archive is being erased, or perhaps translated into a language we do not yet understand. There is something deeply unsettling about this, because it suggests that nothing truly disappears. Even in the darkest regions of the universe, even inside a black hole, the past lingers, encoded in ways that are almost impossible to access, but never fully gone. And yet, as the evaporation continues, the process becomes less gentle. The creation of particle pairs becomes more frequent, the separation more violent. The energy of the escaping particles increases. What was once a faint whisper of radiation begins to grow stronger, more noticeable, more insistent. The black hole is no longer just fading, it is changing. Its nature, once defined by silence and stillness, is becoming something more dynamic, more unstable. And the horizon, once smooth and perfect, begins to feel less certain, less absolute. Tiny fluctuations ripple across it, not visible, not directly measurable, but present, like the surface of water just before it begins to boil. Something is building, because the closer the black hole gets to its end, the less stable its existence becomes. The balance between gravity and quantum effects, once delicate but steady, is starting to break. And when that balance breaks, the behavior of the black hole may change in ways we do not fully understand. The slow theft of particles may become something else, something faster, something more dramatic. But for now, it continues. This quiet, relentless process. Particles appearing in pairs, being torn apart, one escaping into the void, the other falling into darkness, a cosmic rhythm, a pulse at the edge of nothingness. And with every cycle, the black hole loses a little more of itself. Not through violence, not through collapse, but through an endless series of tiny, invisible betrayals. The universe, it seems, does not need force to undo something so immense. It only needs time. And time, in this age of silence, stretches on long enough to unravel even the most powerful structures ever formed. The black hole continues to shrink. The horizon continues to tighten. The radiation continues to grow. And somewhere deep within this process, the final act is beginning to take shape. Because the smaller it becomes, the faster everything starts to happen. And what was once slow beyond comprehension will not remain slow forever. And so the pace begins to change. For most of its existence, the black hole has lived in a kind of stillness, its decay so slow that it might as well have been eternal. But now something subtle shifts. Not suddenly, not violently, but unmistakably. The smaller it becomes, the faster it fades. At first, this acceleration is almost impossible to notice. A slight increase in the rate of radiation, a barely measurable rise in temperature, a quiet tightening of the event horizon. But unlike before, these changes no longer take unimaginable spans of time. They begin to happen, closer together, more frequently. Time, which once felt irrelevant, starts to gather meaning again. It is as if the black hole has entered a new phase of its existence, a phase not defined by dominance, but by decline. Imagine a massive clock, one that has been ticking so slowly that each second lasts longer than entire civilizations ever could. For eons, its hands barely move. But now, they begin to turn. Still slow, still heavy, but no longer frozen. The countdown has begun. The physics behind this acceleration is deceptively simple. A black hole's temperature is inversely related to its mass. When it is large, it is cold. When it loses mass, it warms. And as it warms, it radiates more energy. More radiation means more mass loss. More mass loss means higher temperature. And higher temperature leads to even more radiation. A feedback loop, a quiet spiral. At first, the loop turns slowly, like a wheel in deep water, but as the black hole shrinks, the resistance fades, the wheel spins faster and faster. This is not a runaway explosion, not yet. But it is no longer the calm fading of earlier ages. It is something more urgent, more alive. If you could stand at a safe distance, far beyond the reach of its gravity, and observe this process, you would begin to notice something new. The radiation is no longer uniform. It fluctuates, shimmers. Tiny bursts of energy emerge from the horizon, each one slightly more intense than the last. Not chaotic, but no longer perfectly smooth. It is like watching the surface of a dying star, except this star is invisible. The black hole, once defined by its ability to trap everything, is now defined by its inability to hold itself together completely. Its grip on reality is loosening. And with that loosening comes instability. The event horizon, the boundary that once seemed absolute, is beginning to behave less like a perfect surface and more like something dynamic, something alive with motion. Not visible motion, but motion in the fabric of space-time itself. Tiny distortions ripple across it, fluctuations in energy, variations in curvature. The horizon is no longer a clean line between inside and outside. It is becoming uncertain. And uncertainty at this scale is not just a concept. It is a force. Quantum effects, once subtle, now begin to compete more directly with gravity. The two great frameworks of physics, once balanced, start to interfere with each other in unpredictable ways. This is where our understanding begins to blur, because we do not yet have a complete theory that unites these forces. We can describe gravity, we can describe quantum mechanics, but here at the edge of a dying black hole, they collide. And in that collision, new possibilities emerge. Some physicists imagine that the event horizon becomes fuzzy, no longer a sharp boundary, but a region of probability, a place where the distinction between inside and outside is not fixed, but fluctuates. Others suggest that the horizon may ripple with energy, like a membrane under tension. And as the black hole shrinks further, these effects grow stronger. The structure that once defined it begins to soften. It is no longer a perfect prison. It is becoming something more fragile. And deep within, whatever remains of the black hole's interior begins to feel the pressure. Not as a force we can easily describe, but as a consequence of the shrinking boundary. The space inside is being compressed, not by new matter, but by the loss of the outer layers that once defined its extent. The walls are closing in. If anything like a center still exists, if the singularity remains as a meaningful concept, it is now being influenced by changes at the boundary. Because the boundary itself is no longer stable, and this raises a profound possibility. What if the interior of the black hole is not isolated? What if it is deeply connected to the behavior of the horizon? If that is true, then as the horizon shrinks and fluctuates, the entire structure of the black hole may be changing from the inside out. Not collapsing, not exploding, but transforming. And as this transformation continues, the flow of time, already strange inside a black hole, may begin to behave in even more unusual ways. Time, which once pointed inevitably toward the center, may lose its direction. Imagine a river that always flows toward a single point. No matter where you stand within it, the current pulls you inward. Now imagine that the river begins to slow, to swirl, to form eddies and loops. The direction is no longer clear. The flow becomes chaotic. Inside the black hole, something similar may begin to happen. The certainty of toward the center starts to break down. And with that breakdown comes a kind of instability that is difficult to visualize. Because when time itself becomes uncertain, cause and effect begin to blur. Events may no longer follow a simple sequence. What happens before and after may lose their meaning. And all of this is happening. Not in a burst, not in a moment of violence, but in a gradual, accelerating unraveling. Outside, the radiation grows stronger. The black hole becomes hotter, smaller, more active. Inside, the structure becomes less certain, more fluid, more strange. And between these two regions, the inside and the outside, the horizon trembles. It is no longer just a boundary. It is a stage, a place where the final acts of this cosmic story are beginning to take shape. The countdown is no longer abstract. It is real, not measured in seconds, but no longer beyond comprehension. The black hole is running out of time, and as it does, the nature of reality around it becomes increasingly difficult to predict. The calm has ended. The slow fade has given way to acceleration. And somewhere within this growing instability, new phenomena begin to emerge. Strange, unsettling, almost impossible. Because as the horizon shrinks further and the quantum effects intensify, some theories suggest that the boundary may not remain a passive surface at all. It may react, it may resist, and it may give rise to something that was never supposed to exist. A barrier not of gravity, but of energy. A threshold not of silence, but of fire. And if that is true, then the final stages of a black hole's life will not be quiet. They will be anything but. And so the boundary begins to draw inward, not in a sudden collapse, not in a dramatic gesture, but in a slow, relentless tightening, like a circle being gently pulled closed. The event horizon, once vast and distant, no longer feels untouchable. It contracts, quietly, patiently. What was once the ultimate edge of no return begins to move. If you could mark its position, if there were anything left in the universe to serve as a reference, you would notice that the boundary is shrinking toward the center. Not because something is pushing it inward, but because there is simply less of the black hole left to define it. Mass is disappearing, energy is escaping, and the horizon must follow. This shrinking is not just a geometric change, it is a deep alteration in the structure of reality around the black hole. Because the event horizon is not a surface in the usual sense, it is not made of matter, it has no thickness you can touch, it is a limit, a condition, a place where the rules of spacetime shift so dramatically that escape becomes impossible. And now, that limit is retreating. Imagine a vast, invisible wall surrounding something you cannot see. For ages, the wall stands firm, enclosing everything within. But slowly, the wall begins to move inward, closing, tightening. Whatever is inside does not grow. The wall simply leaves less and less space for it to exist. This is what is happening to the black hole. Everything that has ever fallen in, every fragment of matter, every photon of light, every trace of structure is still, in some sense, contained, but the region that contains it is shrinking, compressing. And as that compression continues, something strange begins to emerge. Density increases, not because new matter is being added, but because the same content is being confined to a smaller and smaller region. If the concept of a singularity still holds, if there remains a point or region of extreme density at the center, then it is now under new conditions, because the horizon that once protected it is no longer stable. The singularity was never something we fully understood, a place where our equations break down, where density becomes infinite, where the known laws of physics lose their meaning. And yet, for most of the black hole's life, it remained hidden, shielded behind the event horizon, untouchable, unobservable. But now, as that horizon contracts, the relationship between the inside and the outside begins to change. The barrier that once kept the singularity completely isolated is weakening, not opening, not yet, but becoming less absolute. This raises a question that feels almost forbidden. What happens if the horizon becomes too small to contain what lies within? Can a singularity exist without a horizon? Or is the horizon essential to its existence? Some theories suggest that the two are inseparable, that the singularity is not an independent object, but a feature that only makes sense within the context of the horizon. If that is true, then as the horizon shrinks, the singularity itself may be forced to change. Not collapse, not explode, but transform into something else, something less extreme, less infinite, a release of tension in the fabric of spacetime. Other ideas suggest something even more unsettling, that as the horizon shrinks, the singularity may begin to press outward in a conceptual sense, not physically expanding, but becoming less hidden, less confined. The distinction between inside and outside begins to blur, and in that blur, the structure of the black hole becomes uncertain. Because if there is no clear boundary, then what defines the black hole at all? The identity of the black hole, once so sharply defined by its horizon, begins to dissolve. It is no longer a perfectly enclosed region. It is becoming something more ambiguous, a fading structure, a collapsing definition. And within this collapsing definition, the contents of the black hole are no longer simply trapped. They are compressed into a space that is rapidly losing its ability to contain them. Imagine trying to hold water in your hands. At first, your grip is firm, the water stays. But as your fingers slowly open, as the space between them widens, the water begins to slip through. Now imagine the opposite. Your hands are closing. Tighter, tighter. But at the same time, the water itself is changing, becoming less confined by your grip, more fluid, more elusive. This is the paradox of the shrinking black hole. The boundary closes in, but the concept of containment weakens. And deep inside, whatever remains of structure, if structure still exists, must adapt to this new reality. Perhaps the singularity is no longer a point. Perhaps it spreads into a region. Perhaps it dissolves into a field of extreme but finite density. We do not know, because this is where our current understanding ends. But we can follow the consequences. As the horizon continues to shrink, the energy at its edge continues to rise. The radiation grows stronger, the fluctuations more intense, and the pressure on the internal structure increases. Not a physical pressure in the usual sense, but a pressure of consistency, a demand that the laws of physics, whatever form they take here, remain coherent. And that demand may force a transition, a shift from one kind of structure to another, something less absolute, less infinite, more compatible with the outside universe. Because as the black hole loses mass, it is not becoming more isolated, it is becoming more connected. Its influence shrinks, its boundary weakens, its interaction with the surrounding vacuum becomes more significant. The inside and the outside begin to merge in subtle ways. And in that merging, something long hidden may begin to surface. Not matter, not light, but information. The memory of everything that has ever fallen in. Encoded, distorted, scattered across the processes at the horizon. If the horizon is indeed a kind of record, if it stores the imprint of everything the black hole has consumed, then as it shrinks, that record is being compressed, condensed, and possibly released. Not in clear signals, not in recognizable patterns, but in the correlations between the particles that escape. Tiny connections, subtle relationships, hidden in what appears to be randomness. A language too complex to read, but not meaningless. And as the horizon contracts further, these correlations may become stronger, more pronounced, as if the black hole in its final stages is trying to return what it once took, not deliberately, not consciously, but as a consequence of the laws that govern it. A final act of balance, and still the process continues. The horizon shrinks, the radiation intensifies, the internal structure becomes more uncertain. The identity of the black hole fades. It is no longer the same object it once was. It is becoming something else, something transitional, a bridge between existence and disappearance. And as this transformation deepens, the stage is set for even stranger phenomena to emerge. Because when boundaries weaken, when definitions blur, when the fabric of reality is stretched to its limits, new possibilities appear. Some of them beautiful, some of them unsettling, and some that challenge the very idea of what it means for something to exist at all. And now we approach the question that sits at the very center of this quiet unraveling. What happens to the singularity? For so long, it has been treated as the final answer, a point of infinite density, a place where space collapses completely, and time itself comes to an end. Not an object, not a surface, but a breakdown. A place where our understanding simply stops. And yet, everything we have described, the shrinking horizon, the evaporation, the rising temperature, depends on a structure that surrounds it. The singularity has never existed on its own. It has always been hidden, defined by the boundary that encloses it. But now, that boundary is fading. So the question returns, more urgent than ever. Can something infinite survive without the structure that contains it? Or is the singularity itself only an illusion born from incomplete physics? As the black hole loses mass and its horizon contracts, the conditions that once allowed the singularity to exist begin to change. The extreme curvature of space-time at the center, once thought to be unbounded, may no longer behave the same way. Because infinity, in physics, is often not a real thing. It is a signal, a warning that the equations we are using have reached their limit. And here, at the end of a black hole's life, we are far beyond those limits. Some theories suggest that the singularity never truly existed as an infinite point, that instead, it was always a region of extremely high density, governed by laws we do not yet fully understand. Quantum gravity, a framework not yet complete, but one that may replace the idea of infinity with something finite, though still unimaginably extreme. If that is true, then as the black hole shrinks, the singularity does not remain fixed. It evolves. The immense compression at the center may begin to relax, not because matter is escaping directly, but because the overall structure of spacetime is changing. The horizon, which once forced everything inward, is weakening. And without that rigid boundary, the conditions at the center must adjust. Imagine a deep well in the fabric of space. At its center, everything is pulled downward, compressed into a single point. But now, imagine the walls of that well beginning to rise, to soften, to lose their steepness. The pressure at the center would begin to ease. Not suddenly, but inevitably. The singularity, if it exists as a region, may begin to spread, not expanding in the usual sense, but becoming less sharply defined, less absolute. Instead of a point, it may become a cloud of extreme energy and curvature, still dense, still powerful, but no longer infinite. And this transition carries profound implications. Because if the singularity softens, if it becomes something finite, then the entire black hole becomes something else. Not a perfect trap, not an ultimate endpoint, but a temporary structure, a phase. And phases can change. As the evaporation accelerates and the horizon shrinks further, the distinction between the center and the boundary begins to blur. What was once far apart, infinitely distant in terms of space-time structure, may now become connected in unexpected ways. Some theories even suggest that, in these final stages, the internal geometry of the black hole undergoes a radical transformation. Instead of everything pointing inward toward a single end, space-time may begin to loop. Paths that once led only deeper may begin to circle, to fold, to intersect. Time itself, which once flowed inevitably toward the singularity, may lose its direction. Inside the black hole, time is not like time outside. It is not something you can step out of. It is woven into the structure of space-time itself. To move forward in time is to move inward, toward the center. But what happens when the center is no longer well-defined? The flow of time may become unstable. Imagine a river that has always flowed toward a single drain. Now imagine that drain slowly closing, shifting, breaking apart. The water would no longer move in a single direction. It would swirl, eddy, loop back on itself. Inside the dying black hole, something similar may occur. Time may form local loops, small regions where cause and effect circle back, events that influence themselves, moments that do not have a clear beginning or end. Not in a way that creates paradoxes we can easily describe, but in a way that breaks the linear structure we are used to. And within these loops, the concept of before and after becomes uncertain. What happens first? What causes what? The answers may no longer exist in a simple form. This is not chaos in the usual sense. It is a deeper kind of instability, a breakdown of the framework that allows events to be ordered at all. And yet, even as this happens inside, the outside world continues its own transformation. The radiation grows stronger. The black hole becomes hotter, smaller, more intense. The horizon continues to shrink. And the distance between the outer boundary and the inner structure becomes less and less meaningful. Eventually, the entire black hole may exist in a state where inside and outside are no longer clearly separable. A transitional object, neither fully one nor the other. And in that transition, something long hidden may begin to emerge, not as a sudden release, not as an explosion, but as a gradual exposure of what was once concealed. If the singularity is no longer infinitely dense, if it has softened into something finite, then in principle, it may no longer require a horizon to hide it. And if the horizon disappears, what remains? A question with no clear answer. Some possibilities suggest that the black hole leaves behind a tiny remnant, a stable object containing the remaining information. Others suggest that everything is eventually radiated away completely. And still others imagine that the final stages connect to entirely new regions of spacetime. But here, in this moment, this late stage of evaporation, we are not yet at the end. We are at the threshold. The singularity is changing. The horizon is weakening. Time is becoming uncertain, and the entire structure of the black hole is entering a phase unlike anything that came before. A phase where the deepest assumptions of physics are no longer reliable. Where infinity gives way to finiteness, where direction gives way to loops, where boundaries give way to gradients. And as this transformation continues, something even more unsettling begins to take shape at the edge. Because as the horizon becomes unstable, as quantum effects intensify, there is a possibility, still debated, still uncertain, that the boundary itself may undergo a dramatic shift. Not just shrinking, not just fluctuating, but changing its nature entirely, from a passive surface into something active, something that does not merely allow particles to escape, but reacts, something that could turn the quiet edge of a black hole into a place of extreme energy, a threshold not of silence, but of confrontation, a place where anything that tries to cross would not simply pass through, but would encounter something unexpected, something that challenges the very idea of what it means to fall into a black hole. And if that possibility is real, then the final stages of a black hole's life may not be defined by emptiness, but by something far more intense, something waiting, right at the edge. And so, the question deepens. If nothing is truly lost, if every particle, every fragment of light, every structure that has ever fallen into a black hole must in some way be preserved, then where is it? Because from the outside, the story seems simple. A star collapses, a black hole forms, matter falls in, and nothing ever comes back. But the slow evaporation we have been following tells a different story. The black hole is not a perfect vault. It leaks, it fades, it disappears. And if it disappears completely, then whatever it contained must go somewhere. This is the heart of the paradox. For decades, it has lingered at the intersection of gravity and quantum theory, refusing to resolve itself, a quiet contradiction in our understanding of the universe. On one hand, the laws of quantum mechanics insist that information cannot be destroyed. Not truly. It can be scrambled, hidden, transformed into forms that are almost impossible to recognize. But it cannot vanish. On the other hand, the classical picture of a black hole suggests that anything crossing the event horizon is gone forever. Irretrievable. Two truths, both deeply supported, both seemingly incompatible. And now, as the black hole approaches the later stages of its life, this contradiction becomes impossible to ignore. Because the evaporation is not theoretical anymore, not in this story. It is happening. The black hole is losing mass. Radiation is escaping. And eventually, there may be nothing left. So again, the question returns. What happens to the information? Imagine everything the black hole has ever consumed. Stars that once burned with unimaginable heat. Planets that carried oceans, mountains, perhaps even life. Streams of light that traveled billions of years across the cosmos. All of it swallowed. All of it compressed. All of it hidden. Does it simply dissolve into featureless radiation? A final, meaningless noise scattered into the void? Or is there something more subtle happening? Some physicists believe that the answer lies not inside the black hole, but on its surface. The event horizon. Rather than being an empty boundary, it may act as a kind of storage layer, a place where information is encoded, not in a simple readable form, but in patterns, in correlations, in the fine structure of spacetime itself. Every particle that falls in leaves an imprint, a distortion, a change in the horizon's microscopic state, like footprints pressed into soft ground. Over time, these imprints accumulate, layer upon layer, a vast, complex record of everything the black hole has ever absorbed. And as the black hole evaporates, that record does not disappear all at once. It is released, slowly, subtly, not as clear messages, not as images or memories, but as correlations in the radiation. Two particles emitted at different times may be connected in ways that carry hidden information. Patterns that, if you could read them, would reconstruct the history of everything that has fallen in. But reading that information is almost impossible, because the signal is incredibly scrambled. Imagine taking a detailed book, every word, every sentence, and shredding it into tiny pieces, then scattering those pieces across an ocean. The information is still there, in principle. But reconstructing it would require an understanding so deep and a precision so perfect that it borders on the unreachable. And yet, even this possibility is enough to preserve the laws of physics. Information is not destroyed, it is hidden, encoded in the faint whispers of radiation escaping a dying black hole. But not everyone agrees. Some ideas suggest something more dramatic, that as the black hole evolves, there comes a point where the structure of the horizon itself must change to preserve information, a moment where the smooth, silent boundary becomes something else, something that does not gently encode information, but actively prevents it from being lost. This leads to one of the most unsettling possibilities in modern physics: the idea that the horizon is not empty, not passive, but filled with energy, an intense, almost violent region where the rules shift abruptly. If this is true, then the horizon may act like a barrier, a firewall, not made of matter, but of extreme quantum effects. A place where any incoming object would not pass quietly into the black hole, but would encounter something unexpected, something destructive, its structure torn apart, its information released or transformed at the boundary itself. In this view, the inside of the black hole may not even exist in the way we imagine. The horizon becomes the key, the place where everything happens, a surface not of silence, but of activity, a surface where the past is stored and the future is determined. This idea is controversial because it challenges a deeply held assumption that crossing the event horizon should feel uneventful, that locally nothing special happens at that boundary. But if a firewall exists, that assumption breaks. The horizon becomes a place of extreme consequence. And as the black hole shrinks, as its final stages approach, the conditions that might give rise to such a phenomenon become more likely. The energy at the horizon increases, the fluctuations intensify, the need to preserve information becomes more urgent. Something has to give. Either information escapes in subtle, encoded ways, or the structure of spacetime itself changes to ensure it is not lost. Both possibilities are strange. Both challenge our intuition. And both suggest that the final stages of a black hole's life are far more complex than a simple fade into nothingness. Because this is not just about mass, not just about energy. It is about the fundamental consistency of the universe, about whether the laws we trust continue to hold, even in the most extreme conditions imaginable. As the black hole continues to shrink, this question becomes more pressing. The horizon tightens, the radiation grows stronger, the internal structure becomes less certain, and the information, the memory of everything that has ever fallen in, remains at the center of it all, waiting, not to be destroyed, but to be accounted for, in one way or another. And as we move closer to the final phases, the tension between these possibilities begins to build, because something has to resolve. The universe cannot hold a contradiction forever, and when that resolution comes, it may not be quiet. It may not be gentle. It may reshape our understanding of what a black hole truly is. Not a place where things end, but a place where the deepest rules of reality are tested and possibly rewritten. And as the tension builds, something even more elusive begins to shift. Not just energy, not just matter, but time itself. Inside a black hole, time has never behaved the way it does elsewhere. It does not flow freely. It does not stretch gently into the future. It points. In the deep interior, time is tied to direction. To move forward in time is to move inward, closer to the center, closer to whatever lies at the core. There is no turning back, no pausing, no drifting sideways, only forward and inward. But now, as the black hole shrinks, as the horizon contracts and the internal structure begins to soften, that direction starts to lose its certainty. The center is no longer clearly defined. The singularity, if it still exists, has changed. It is no longer an absolute destination. And when the destination becomes uncertain, the path toward it begins to waver. Time, once a straight descent, begins to bend. At first, the change is subtle, almost impossible to notice. The flow inward is still dominant, still present. But small irregularities begin to appear, tiny deviations, moments where the progression is not perfectly smooth. Like a river encountering hidden currents beneath its surface, the flow continues, but not without disturbance. As evaporation accelerates and the horizon tightens further, these disturbances grow. The geometry of spacetime inside the black hole becomes increasingly complex. No longer a simple funnel leading to a single point, but a shifting landscape. Curves within curves, paths that twist, regions where direction is not singular, but ambiguous. And in that ambiguity, something extraordinary may begin to happen. Time may loop, not in the dramatic sense of repeating entire histories, not in grand cycles, but locally, subtly, small pockets where cause and effect begin to circle back. Imagine a moment that does not simply pass, but folds, a moment that influences itself, an event that is both the cause and the consequence of its own existence. Within these loops, the usual order of events dissolves. What comes first, what follows? the distinction begins to blur. This does not create simple paradoxes like stories where someone meets their past self. It is deeper than that, more abstract. Because it is not the events themselves that repeat, but the structure of time that allows repetition to exist at all. Time loses its arrow. Or rather, it gains many small arrows, pointing in different directions, intersecting, overlapping. A network instead of a line. And within that network, the concept of before and after becomes a matter of perspective. From one path, an event may appear to happen first. From another, it may appear to come later. Both can be true. This is not something we can easily picture, because our minds are built around a single flow of time, a sequence, a narrative. But inside the dying black hole, that narrative begins to fragment, and as it fragments, the very idea of history becomes unstable. What happened inside the black hole may no longer have a single consistent story. Instead, it becomes a web of possibilities, interconnected, interdependent. A structure where information is not stored in a linear record, but in relationships. And this may connect in a profound way to the problem of information itself. If information is encoded not in a sequence, but in a network of correlations, then perhaps it does not need a single timeline to exist. It can survive, even when time itself becomes uncertain. In this view, the strange behavior of time inside the black hole is not a flaw, not a breakdown, but a feature. A way for the universe to preserve consistency even under extreme conditions. A way to hold on to information without requiring a simple, linear history. Outside the black hole, the radiation continues, growing stronger, more energetic. From the outside, time still flows normally. The black hole shrinks, its temperature rises, its lifespan shortens. But inside, time is no longer aligned with that external flow. The two regions, inside and outside, are beginning to diverge not just in space, but in temporal structure. And as the horizon continues to contract, the separation between these two realities weakens. The loops inside may begin to influence the patterns outside. Not directly, not in a way that sends clear signals, but through correlations, subtle connections in the radiation. Tiny fingerprints of the internal complexity imprinted on what escapes. If this is true, then the radiation is not just energy. It is a projection, a shadow of the internal structure, a way for the tangled, looping time inside the black hole to express itself in the linear time outside. Distorted, scrambled, but present. And as the black hole approaches its later stages, these effects may intensify. The loops become more pronounced, the internal structure more dynamic. The distinction between a single timeline and a network of possibilities becomes more blurred. And all of this is happening as the black hole itself continues to shrink. The horizon tightens, the boundary weakens, the radiation grows, and time, once simple in its direction, becomes something far more intricate, something layered, something that resists being reduced to a single flow. This transformation is not violent. It does not announce itself. It unfolds quietly. But its implications are profound. Because if time can behave this way, even in one region of the universe, then the nature of time itself may be more flexible than we ever imagined. Not a fixed background, not an absolute stage, but something that can bend, twist, and reorganize itself under extreme conditions. And as we move closer to the final stages of the black hole's life, this flexibility may become essential. Because what lies ahead will push the limits not just of gravity, not just of quantum mechanics, but of time itself. And when those limits are reached, something new may emerge at the boundary. Not just fluctuations, not just radiation, but a transformation so intense that the horizon may no longer behave like a boundary at all. It may become something else entirely, a place where energy builds, where structure forms, where the quiet loops of time and the rising heat of evaporation converge into something unexpected. Something that was never part of the original picture. And if that transformation happens, then the final moments of a black hole will not be defined by silence, but by a strange and luminous instability, waiting, just beyond the edge. And at the edge, where everything has always seemed quiet, something begins to gather. Not matter, not light, at least not in the way we usually understand it, but energy, dense, restless, unstable. For most of its existence, the event horizon has been a place of stillness, a perfect boundary where nothing special appears to happen from the perspective of anything falling through it. A smooth crossing, a silent transition. But now, in these final stages, that calm assumption begins to fracture. Because the demands placed on the horizon are no longer gentle, it must allow radiation to escape. It must preserve information. It must remain consistent with both quantum mechanics and gravity. And as the black hole shrinks, these demands begin to conflict. The delicate balance that once allowed the horizon to remain passive begins to strain. Something has to change. One possibility, still debated, still uncertain, but impossible to ignore, is that the horizon becomes active. Not just a boundary, but a barrier, a region where energy accumulates rather than disperses. Imagine the surface of a star, not its calm glow from a distance, but its true nature up close, a seething layer of plasma, charged particles colliding, energy surging in constant motion. Now imagine something even more extreme, a surface where the energy is not spread out over vast space, but compressed into an unimaginably thin region, where quantum effects are no longer subtle, but dominant. This is the idea of the firewall, not a wall in the ordinary sense, not something you could touch, but a region at the horizon where the energy density becomes so high that anything attempting to cross it would encounter a violent transformation. Instead of slipping quietly into the black hole, it would be met with intensity. Its structure disrupted, its information forced into new forms. In this picture, the horizon is no longer invisible. It is no longer passive. It becomes a threshold of extreme consequence. And this possibility arises not from imagination, but from the tension we have been following. If information must be preserved, and if the radiation must carry that information away, then the horizon may need to play a more active role. It cannot simply let things pass through unchanged. It must process them. And processing at this scale may not be gentle, but this idea challenges something deeply ingrained in our understanding. For a long time, it was believed that crossing the event horizon of a sufficiently large black hole would feel uneventful. No sudden forces, no dramatic changes. Because, locally, the curvature of space-time at the horizon could be small. But a firewall changes that. It suggests that the horizon itself is a place of extreme energy, regardless of the size of the black hole. A place where the smooth fabric of space-time breaks, where the assumptions of calm passage no longer apply. And as the black hole shrinks, the conditions that might give rise to such a phenomenon become more plausible. The temperature rises, the radiation intensifies, the quantum fluctuations grow stronger. The horizon becomes a more active region, more energetic, more unstable. If a firewall forms, it would not appear suddenly in a flash. It would build. Gradually, as the evaporation accelerates, the energy near the horizon could begin to concentrate. Tiny fluctuations grow larger. Interactions become more frequent, until the boundary is no longer quiet, but turbulent, a storm of quantum activity. Not visible in the traditional sense, but real. A region where the separation between inside and outside is no longer smooth, but abrupt. And this raises a striking image. For most of its life, the black hole has been defined by darkness, a place where light cannot escape. But now, at its edge, something like a glow begins to emerge. Not yet bright, not yet visible as light we could see, but present as energy, a faint radiance. And as the black hole continues to shrink, that radiance grows. From a whisper to something more pronounced. The temperature increases, the spectrum of the radiation shifts. From long, low-energy wavelengths towards shorter, more energetic ones. If this process continues, and there is every reason to believe it will, the black hole may begin to emit radiation that, in principle, could be seen. A paradox made visible. The darkest object in the universe beginning to shine. At first, the glow would be weak, infrared, barely distinguishable from the surrounding void. But as the mass decreases further, the temperature rises more quickly. The emission moves through the spectrum, toward visible light, toward something brighter, more intense. The black hole, once perfectly black, becomes something else. A source, and if the firewall exists, or something like it, the region at the horizon may contribute to this transformation. The energy concentrated there could enhance the emission, turning the boundary into a kind of luminous shell, a surface not of darkness, but of radiance, still thin, still subtle, but growing. This does not mean the black hole suddenly becomes a star. Its structure is entirely different. Its process is far more extreme. But the idea remains. It is no longer defined only by what it takes, but by what it gives. And what it gives becomes more intense with every passing moment. As the evaporation accelerates, the balance shifts further. The radiation increases, the temperature climbs, the horizon shrinks more rapidly. The internal structure, already unstable, continues to evolve, and the boundary between inside and outside becomes more dynamic. If there is a firewall, it is now stronger, more active. If there is no firewall, then something else must take its place to resolve the same tensions. Either way, the horizon is no longer simple. It is no longer a passive edge. It is a region of transformation, a place where the deepest principles of physics are being tested. And as we move closer to the final stages, the calm evaporation of earlier times is replaced by something more urgent, more energetic, more luminous. The black hole is heating up. Its presence, once defined by absence, is becoming harder to ignore. Even in a universe where nothing else remains, it begins to stand out, a point of activity, a beacon in the deepest dark. And this beacon is not stable. It is changing faster now. The feedback loop we followed before is tightening. Less mass, more temperature, more radiation, even less mass. The cycle accelerates. What once took ages now unfolds more quickly. And with that acceleration comes a sense of inevitability, because this process cannot continue forever. There is a limit, a point where the remaining mass becomes so small, the temperature so high, the radiation so intense, that the black hole can no longer maintain even its shrinking structure. A final threshold, beyond which the slow fade gives way to something else entirely, something sudden, something violent, a last act that will release everything that remains. And as the horizon glows and the energy builds, that final moment draws closer, waiting just beyond the edge of time. And now, the darkness begins to change. For so long, the black hole has been defined by what it refuses to reveal. No light, no surface, no sign of what lies within. But as the final stages draw closer, that identity begins to dissolve. Because the temperature continues to rise, what was once colder than the faintest remnants of the early universe is no longer cold at all. It warms, then heats, then intensifies. At first, the radiation remains subtle, invisible, a soft leakage of energy into the void. But as the mass decreases further, the spectrum shifts. The energy of the emitted particles increases. What began as long, low-frequency waves spread thin across the darkness begins to compress into shorter wavelengths, from deep infrared towards something more energetic, something that in another context might be seen. The black hole begins to glow, not like a flame, not like a star, but like a presence. A faint shimmer against the absolute blackness of everything else. If there were eyes left to see it, they would notice. At first, only barely. A subtle warmth, a whisper of light. But it does not remain that way, because the feedback loop continues. Less mass means higher temperature. Higher temperature means more radiation. More radiation means even less mass. The cycle tightens. The increase is no longer gentle. It becomes noticeable, then undeniable. The glow strengthens. What was once infrared creeps toward visible wavelengths. A dull red, perhaps. Faint, unsteady, then brighter. The black hole, once a perfect void, now carries a fragile halo of energy. Not a solid surface, but a region where emission is strong enough to leave a mark. It is no longer just darkness. It is something else, a contradiction. Because how can something defined by the absence of light begin to shine? And yet it does. Not by reflecting light. Not by revealing what lies inside, but by giving off its own energy. The darkness itself is unraveling. As the temperature climbs higher, the radiation becomes more intense. The spectrum broadens, from red to white, a pale, ghostly brightness, still small, still distant in the vast emptiness of the universe, but growing. If one could measure its output, it would no longer be negligible. It would stand out, a point of energy in a universe otherwise drained of activity. The last ember. But this ember is not stable. It is not sustained by fusion like a star. It is not balanced by internal pressure. It is driven by loss, a self-consuming process, and because of that, it does not settle into equilibrium. It accelerates. The smaller the black hole becomes, the faster everything happens. Its temperature rises more sharply. Its radiation intensifies more quickly. Its remaining mass disappears more rapidly. Time, which once stretched endlessly, now seems to compress around it. Events that would have taken unimaginable durations now unfold in shorter and shorter intervals. The black hole is no longer fading. It is racing. And as it races, its appearance transforms further. The glow becomes brighter, more concentrated, not spread across a wide region, but focused near the shrinking horizon. If the idea of a firewall or any form of energetic boundary is correct, this is where it would be most visible. A thin, radiant shell, a surface of extreme energy, not stable, not smooth, but flickering, fluctuating. The emission may no longer be uniform, bursts of higher intensity, moments of relative calm, a dynamic, restless output, like the final breaths of something that has no choice but to end. And as the energy increases, new kinds of particles may be emitted. Heavier particles, more complex interactions. The black hole is no longer limited to the simplest forms of radiation. Its temperature is now high enough to access deeper layers of physics. Processes that were once suppressed now become possible. And with each new channel of emission, the mass decreases even faster. The feedback loop tightens further. At this stage, the black hole is no longer just a passive object responding to its environment. It is an active participant in its own disappearance. Its very nature drives it toward its end. And yet, even now, something deeper is unfolding. Because the radiation is not just energy. It carries structure, patterns, correlations that may encode the information we have been following. As the emission intensifies, these patterns may become more pronounced. Not easier to read, but richer, more densely packed with the history of what has fallen in. If the horizon has been storing information, if the evaporation has been releasing it slowly, then now, in these accelerated stages, that release may become more concentrated, more urgent, as if the black hole is running out of time to return what it once absorbed. The glow brightens, the emission strengthens, the patterns deepen, and the structure of the black hole continues to shrink. The horizon contracts more rapidly now. The distance between inside and outside becomes vanishingly small. The internal structure, already unstable, approaches a limit. A point where it can no longer be sustained in its current form. And as that point approaches, the behavior of the black hole becomes increasingly unpredictable. Not chaotic in a random sense, but sensitive. Small changes lead to larger effects. Fluctuations grow. The system is nearing a threshold. A critical point, beyond which the slow, accelerating glow will give way to something else, something sudden, because there is a limit to how hot something can become, before it cannot remain stable. And the black hole is approaching that limit. Its size shrinks toward scales that challenge the very meaning of space. Its temperature rises toward extremes that surpass anything that once existed in the universe. Its lifetime, once vast beyond comprehension, is now collapsing into a final stretch. The last moments are not quiet. They are building. Energy accumulates. Radiation intensifies. The glow becomes undeniable. A final transformation is underway. The black hole is no longer a silent void. It is a blazing point, a last light in a universe that has otherwise gone dark. And that light is not fading. It is rising towards something inevitable, toward a moment where the balance finally breaks, where the slow loss becomes a sudden release, where everything that remains is let go. And as the light intensifies, something deeper begins to falter. For most of its existence, the black hole has been defined by one thing above all else: gravity, an overwhelming pull, a force so strong it could bend light, tear apart stars, reshape entire galaxies. It was the architect of motion, the keeper of structure, the reason anything near it moved the way it did. But now, that force is weakening, not suddenly, not collapsing all at once, but steadily. With every particle that escapes, with every fragment of energy released into the void, the mass decreases, and with less mass, the pull of gravity softens. At first, the change is subtle, almost unnoticeable, but as the black hole shrinks further, the weakening becomes more apparent. The curvature of space-time around it begins to relax. The deep well it once carved into the fabric of reality becomes shallower, less absolute. If there were anything left nearby, any particle, any trace of matter, it would feel this change. The pull would not be as sharp, not as final. The paths that once curved inevitably inward might now bend more gently, perhaps even escape. But in this era, there is nothing left to orbit, nothing left to fall. Only the geometry remains. And that geometry is shifting. The black hole, once a fixed anchor in spacetime, is becoming less stable as a source of gravity. Its influence contracts along with its horizon. What was once vast now becomes localized, contained, and yet within that shrinking region, something strange begins to happen. Gravity does not simply fade into nothing, it fluctuates. The smooth curvature of spacetime begins to ripple, not in visible waves, but in subtle distortions. Tiny variations in the strength of the gravitational field, irregularities that grow as the black hole loses its stability. Imagine the surface of a calm lake, perfectly still, reflecting everything with clarity. Now imagine a disturbance, a small drop of water, ripples spread outward. At first gentle, but if the disturbance continues, if energy keeps entering the system, the ripples become more complex. They overlap, interfere. The surface is no longer smooth. This is what begins to happen to gravity itself around the dying black hole. Not a single stable pull, but a shifting pattern, a trembling. And as the evaporation accelerates, these fluctuations grow stronger. The black hole is no longer a steady source of gravity. It becomes dynamic, unstable. Its gravitational field pulses, not with regular rhythm, but with irregular bursts, moments of slightly stronger pull, followed by moments of relative weakness. Tiny differences, but growing. And these fluctuations do not remain confined. They propagate through spacetime itself as gravitational waves. Not the kind produced by massive collisions or merging black holes in the earlier universe, but something quieter, more subtle, a trembling rather than a crash. These waves carry information about the changing structure of the black hole. They are the echoes of its instability, the sound of gravity losing its certainty. If there were detectors left, if there were observers, they would not hear a roar. They would sense a low, shifting hum. A pattern of vibrations spreading through the emptiness. A final signature of something that once dominated entire galaxies, now reduced to a flicker, a trembling point. And as these gravitational fluctuations continue, they begin to interact with the radiation we have been following. Energy and spacetime no longer acting independently, but influencing each other. The emission of particles affects the curvature. The changing curvature affects the emission. A feedback loop, not just within the black hole, but between the black hole and the fabric of the universe itself. This interaction may create subtle patterns in the radiation, modulations, variations that reflect not only the temperature, but the instability of gravity, a deeper layer of information, hidden within the light. As the black hole shrinks further, the scale of these effects changes. The region of influence becomes smaller, but the intensity within that region increases. The fluctuations grow sharper, more pronounced. The trembling becomes more noticeable. Gravity, once the most stable and dominant force in this system, is now losing its coherence. It is no longer the unshakable foundation. It is becoming uncertain. And this uncertainty has consequences, because gravity is not just a force, it is the structure of spacetime itself. To weaken gravity is to loosen the shape of reality, to make it less rigid, more flexible, more susceptible to change. And as that flexibility increases, the boundary of the black hole becomes even less defined. The horizon, already shrinking, now exists within a spacetime that is no longer stable. Its position fluctuates, not in large visible shifts, but in subtle variations, a trembling edge, a boundary that cannot decide exactly where it is. And within that trembling, the distinction between inside and outside becomes even more blurred. Not just because of quantum effects, but because the very geometry that defines those regions is shifting. This is the final weakening of the black hole's identity. It is no longer a fixed object in spacetime. It is a process, a dynamic, evolving system, one that is losing its defining features: mass, horizon, gravity, all fading, all fluctuating, all approaching a limit. And as that limit draws near, the fluctuations grow stronger. The trembling deepens. The gravitational waves become more complex. A pattern begins to emerge. Not random, not chaotic, but structured. A kind of music, not sound in the traditional sense, but a pattern of oscillations, a frequency, a composition written in the fabric of spacetime, the final song of the black hole. Each fluctuation a note, each ripple a tone, a slow, haunting melody spreading through the empty universe, carrying with it the imprint of everything the black hole has been, its mass, its history, its final transformation. And as the melody continues, it begins to change. The frequencies rise, the oscillations become faster, more intense. The song accelerates, just as the evaporation does. A convergence of processes, radiation increasing, gravity weakening, time becoming unstable, all moving toward the same conclusion. A final state, where the black hole can no longer sustain even its fluctuating existence, where the trembling reaches a peak, and the structure, already fragile, approaches collapse. Not inward, but outward. A release. Because when gravity can no longer hold, when the fluctuations become too strong, something must give. And what follows will not be quiet. The gentle hum, the trembling song, will rise, sharpen, and then break. And as the trembling deepens, the universe begins to listen. Not with ears, not with senses, but with the very fabric of space-time itself. Because what is unfolding now is no longer just a quiet decay. It is becoming a signal, a pattern of motion, a rhythm of distortion, a song. For most of cosmic history, black holes have spoken in rare, dramatic bursts, collisions, mergers, moments where massive bodies spiral together and release torrents of gravitational waves. But this is different. There are no companions here, no galaxies left to collide, no matter to fall in, only a single black hole nearing its end. And yet, it is not silent. Its instability, its fluctuations in gravity, its rising temperature, its shrinking horizon, all combine into something that can only be described as a kind of music. Not sound traveling through air, but oscillations traveling through space-time. If there were a way to translate these waves into something audible, it would not be a sharp noise, not a sudden crash. It would be low, deep, a slow, evolving tone, at first almost imperceptible, a faint vibration. But as the black hole continues to lose mass, the frequency rises, the oscillations become quicker, the pattern becomes more intricate, like a melody that is slowly accelerating. Each fluctuation in gravity contributes a note. Each burst of radiation adds texture, and together they form a composition unlike anything that existed in the earlier universe. A solitary performance, the final expression of something that once defined entire galaxies, now reduced to a point, yet still capable of shaping space-time itself. This music is not random. It carries information. Just as the radiation carries subtle correlations, the gravitational waves reflect the internal state of the black hole. Its mass, its rate of change, its instability, all encoded in the rhythm of its oscillations. If one could read this pattern, if one could understand the language of these waves, it might be possible to reconstruct the story of the black hole's final moments. Not in images, not in words, but in frequencies, in variations of curvature, a translation of history into motion. And as the evaporation accelerates, the music becomes more intense. The tones rise. The intervals shorten. The structure becomes more complex. What began as a low, steady hum transforms into something sharper, more urgent. The black hole is no longer just fading. It is performing its ending, and there is something almost melancholic about it. Because this is not a violent destruction. Not yet. It is a gradual release, a letting go. Each oscillation a sign that something is being lost. Each wave a trace of what once was. And yet, even as it fades, the black hole leaves behind this pattern. A final imprint on the universe, a memory written into space-time itself. But the melody does not remain gentle. As the black hole shrinks further, the feedback loops tighten, radiation increases, temperature rises, gravity weakens, fluctuations grow stronger. All of these processes feed into the oscillations. The music becomes faster, more intense. What was once a smooth progression becomes jagged. Sharp changes in frequency, sudden variations in amplitude. The calm structure gives way to something more chaotic. Not disorderly, but strained. As if the system is being pushed beyond its limits. And in a sense, it is. Because there is only so much instability that can be sustained. Only so much fluctuation that can exist before the structure itself breaks. The black hole is approaching that threshold, the point where the gradual processes we have followed, evaporation, fluctuation, radiation, can no longer continue in the same way. The point where the system must transition. And the music reflects this. It becomes tighter, more compressed. The frequencies climb higher. The oscillations occur in rapid succession. The pattern becomes dense, almost overwhelming. If it could be heard, it would no longer feel like a slow melody. It would feel like a rising tone, a buildup, a tension that cannot be sustained. And yet, within that tension, there is still structure, still meaning. Because even in its final moments, the black hole is not random. It is governed by laws, by relationships between energy, mass, and space-time. And those relationships continue to shape the pattern. The song is not breaking down. It is reaching its climax. And as it does, something remarkable happens. The gravitational waves and the radiation begin to intertwine more deeply. The fluctuations in space-time influence the emission of particles. The emission of particles influences the fluctuations. The two processes, once distinct, become coupled, a single, unified expression of the black hole's state. Light and gravity moving together, a final convergence. And within this convergence, the information we have been following may become even more densely encoded. The correlations in the radiation, the patterns in the waves, all intertwined. A last opportunity for the universe to preserve what has passed through this object, not as a clear record, but as a complex, interwoven signal. And then the acceleration becomes undeniable. The time between changes shrinks rapidly. What once took vast spans of existence now unfolds in moments, still long by human standards, perhaps, but fleeting in cosmic terms. The black hole is nearing its final phase. The music is reaching its peak. The oscillations are at their highest intensity. The radiation is at its strongest. The structure is at its most fragile. Everything is converging toward a single point, a moment where the gradual gives way to the sudden, where the build-up can no longer continue, and something must happen. The melody cannot rise forever. The tension cannot increase without limit. There is an end, a final note, and when it arrives, it will not be quiet. It will not fade gently into silence. It will release everything that remains, a last burst, a final expression of energy, structure, and information, the culmination of everything the black hole has been. And as that moment approaches, the song grows sharper, brighter, faster, until the universe itself seems to hold its breath, waiting for the final note to strike. And then the scale collapses. For most of its life, the black hole has been immense, a structure so large that entire star systems could disappear within its reach. Even as it began to fade, even as it lost mass over unimaginable stretches of time, it still remained vast, far beyond anything familiar. But now, that vastness is gone. The shrinking has accelerated to the point where size itself begins to lose its meaning. What was once measured in kilometers, then meters, then smaller and smaller still, now approaches the scale of the very building blocks of matter. An object that once shaped galaxies is becoming microscopic, and yet despite its size, its influence does not vanish. In fact, it intensifies, because as the black hole becomes smaller, its temperature rises dramatically. What was once a cold, distant presence is now something else entirely. Hot, not warm in any ordinary sense, not like a star, but extreme. Its temperature surpasses that of any known stellar object, higher than the hottest stars that ever burned in the early universe, higher than the violent cores of collapsing supernovae. Because this heat is not sustained by fusion, it is not balanced by pressure, it is driven by the final stages of evaporation, a concentration of energy into an ever smaller region. Imagine compressing all the heat of a star into something the size of a grain of sand. Now imagine compressing it further and further, until size itself becomes almost irrelevant. That is the state the black hole is approaching, a tiny point radiating with unimaginable intensity. If there were anything left nearby, it would be overwhelmed, not by gravity, which is weakened, but by energy. The radiation pouring from the black hole is no longer subtle. It is no longer a faint whisper. It is a torrent, high-energy particles, short wavelength radiation, a flood of emission that grows stronger with every passing moment. The glow we followed before, infrared, then visible, has now moved far beyond, into the realm of high-energy light, X-rays, gamma rays, the most energetic forms of radiation the universe can produce. And all of it is coming from something smaller than an atom. A contradiction so extreme that it feels almost impossible, and yet it is the natural consequence of everything that has come before. The feedback loop has reached its peak. Less mass, higher temperature, more radiation, even less mass. The cycle is now so tight, so rapid, that the black hole's remaining lifetime is collapsing. What once stretched across trillions of years is now compressed into a final phase. moments, still long compared to human experience, but fleeting on the scale of the cosmos. The black hole is no longer slowly fading. It is burning, not with a stable flame, but with a rising intensity that cannot be sustained. And within this final stage, something profound is happening. The boundary, the horizon that once defined the black hole, is now extremely small, almost indistinguishable from the internal structure. The separation between inside and outside is nearly gone. What remains is a compact region where all the processes we have followed, radiation, fluctuation, information encoding, are happening at once, densely, rapidly. And within this region, the information that has been preserved, that has been slowly released, may now be emerging at its highest rate. Not in clear form, not in anything that could be easily reconstructed, but in the sheer density of correlations. The outgoing radiation is no longer sparse, it is rich, layered with the history of everything the black hole has ever absorbed. Every star, every particle, every photon, all encoded in patterns too complex to read directly, but present. If there were a way to capture it all, to analyze every particle, every correlation, it might be possible to reconstruct the past. Not perfectly, not simply, but in principle. And this makes the final stage of a black hole's life something extraordinary. It is not just an ending, it is a release, a return of information to the universe, compressed, scrambled, but not destroyed. And as this release accelerates, the energy output becomes staggering. The black hole is now one of the most energetic objects that could exist in this empty universe. A tiny point, outshining everything that once was, and yet it cannot last. Because the process that drives this intensity is also what destroys it. The more it radiates, the faster it loses mass. The faster it loses mass, the hotter it becomes. The hotter it becomes, the more violently it radiates. A runaway effect, a final surge. And this surge pushes the black hole toward a limit. A point where the remaining mass is so small, the energy so concentrated, that the structure cannot hold. Not even in its fluctuating, unstable form. The laws that have guided its behavior, gravity, quantum mechanics, are now being pushed to their extremes. The scale approaches what we call the Planck regime, a domain where our current understanding breaks down, where space and time themselves may lose their continuous nature, become discrete, fragmented, where the distinction between energy and geometry becomes unclear. And in this regime, predictions become uncertain. We can follow the trends, we can understand the direction, but the exact details of what happens next remain hidden. And yet, one thing is clear. The black hole cannot continue like this. The acceleration cannot go on indefinitely. The energy cannot increase without bound. There must be a final transition, a moment where the remaining mass is released, where the structure gives way completely, and everything that remains is let go. This is the threshold, the last stage before the end. The black hole is now smaller than anything we can easily imagine, hotter than anything that has ever existed, more dynamic than at any point in its history, and its lifetime is almost over. The buildup is complete. The energy is at its peak. The structure is at its limit. All that remains is the final act, a moment that will not stretch across ages, but will happen in an instant. And then it happens, not slowly, not gently, but all at once. For so long, everything has been building toward this moment, the shrinking, the heating, the tightening of the horizon, the rising intensity of radiation, all of it leading here, the final release. At the very last instant, the black hole is no longer a stable structure, not even an unstable one. It is a system pushed beyond its limits. The remaining mass, now incredibly small, is paired with an enormous temperature. Energy is no longer leaking out. It is erupting. What had been a steady, accelerating flow of radiation suddenly surges. The feedback loop, mass decreasing, temperature rising, reaches a point where it can no longer be sustained in gradual form. It collapses into a burst, a final flash, a release of energy so concentrated, so intense, that it dwarfs everything that came before. Gamma rays flood outward. High-energy particles explode into the surrounding void. A brilliant, violent emission from something that, only moments ago, was smaller than an atom. If there were anything left nearby, it would be bathed in this radiation, overwhelmed by it. But in this empty universe, there is nothing to receive it. The energy expands into the darkness, unopposed. A sphere of light racing outward at the speed of causality itself. This is not a slow fading. It is not a quiet disappearance. It is an ending with a final statement, a declaration that even the darkest, most silent objects in the universe carry within them the potential for brilliance. The magnitude of this burst depends on what remains at that final moment. But the principle is clear. All the mass that has not yet been radiated away, all the energy still bound within the black hole's shrinking structure, is released, not gradually, but in a single, explosive event, a final transformation of mass into energy. And in that transformation, something else is released as well. Information. The correlations that have been building within the radiation, the patterns encoded at the horizon, all of it reaches its most concentrated form, not as a clear message, not as something that could be easily read, but as a dense, complex structure within the outgoing burst. If it were possible to capture every particle, every wave, every fluctuation within that final flash, it might contain the complete story of the black hole, everything it has ever been, everything it has ever consumed, all compressed into a moment, a final imprint. But this moment is brief, incredibly brief. The release happens so quickly that, in cosmic terms, it is almost instantaneous. The buildup of trillions upon trillions of years resolved in a flash. And then, it is over. The black hole is gone, not hidden, not transformed into another stable object. Gone. There is no horizon, no boundary, no center. The structure that once defined it has completely dissolved. What remains is only what has been emitted. Energy spreading outward, particles racing through the void, waves of radiation carrying the final signature of what once existed. And for a moment, just a moment, there is light. In a universe that has long since gone dark, a final illumination. Then it fades. Not because it is absorbed. There is nothing left to absorb it, but because it spreads, diluting into the vastness of space, its intensity decreasing as it expands. The burst becomes a glow. The glow becomes a trace. The trace becomes indistinguishable from the background emptiness. And just like that, the last visible act of the black hole is complete. But the consequences remain. The energy continues to travel. The information continues to exist within it. The ripples in space-time generated by the sudden release propagate outward, a final echo, a last disturbance in an otherwise silent universe. At the location where the black hole once existed, something subtle is left behind. Not an object, not a remnant in the traditional sense, but a change. A region where the structure of space-time has been pushed to its limits, where the final event has left its mark. Some theories suggest that this moment, this final burst, may involve effects we do not fully understand. At such extreme energies, at such small scales, the nature of space and time themselves may behave differently. There could be fluctuations, tiny, transient features, quantum effects that briefly reshape the local structure. But whatever happens in those final instants, it does not persist. There is no stable remnant, no lasting object, only the aftermath. Energy, radiation, and the memory encoded within it. The black hole, which once stood as the ultimate absorber, has completed its transformation into a source. And now even that role is finished. The emission has ended. The process is complete. The last of its mass has been converted. The last of its structure has dissolved. The last of its presence has faded. And in its place, there is nothing. No darkness. No light. Just the quiet continuation of an empty universe. But something has changed, because where once there was a singular dominant object, there is now only the trace of its existence, spread across space, carried by particles that will travel forever. The black hole is gone, but its story has not vanished. It has been written into the universe itself. And though no one remains to read it, the record endures, fading, but never entirely lost. And in the instant after the flash, something even more subtle lingers. Not light, not matter, but a disturbance. The explosion is over. The energy has begun its long journey outward. But the place where the black hole once existed is not entirely unchanged, because what just occurred was not a simple release of energy. It was a transformation that pushed space-time itself to its limits. At the very center of that final moment, where the remaining mass vanished into radiation, the structure of space and time was stretched, compressed, and reshaped in ways we do not yet fully understand. For a brief instant, perhaps shorter than anything we can meaningfully measure, the fabric of reality may have torn. Not in a visible sense, not like a rip in cloth, but in a deeper, more abstract way. A breakdown of continuity, a place where the smooth geometry of spacetime gave way to something more granular, more uncertain, a quantum scar. Imagine a perfectly calm surface, smooth, unbroken. Then, for the briefest moment, a force strikes it with such intensity that the surface cannot respond in its usual way. It does not simply ripple, it fractures microscopically temporarily, but enough to leave a trace. Then it settles again. To any distant observer, nothing unusual remains. But at the point of impact, something has changed. This is what may be left behind. Not a lasting object, not a remnant that persists in the usual sense, but a subtle alteration in the structure of spacetime. A region where the geometry has been pushed beyond its usual limits and then returned. The effects of such a scar would be incredibly small, so small that in a universe filled with matter and activity, they would likely go unnoticed. But here, in the deep emptiness that remains, there is nothing to mask them. The universe is quiet enough that even the faintest traces could in principle persist. Tiny fluctuations, residual patterns, echoes of the extreme conditions that once existed there. But even these are not permanent, because spacetime, like everything else, tends toward equilibrium. The disturbances smooth out, the irregularities fade, the geometry relaxes, and over time, vast, unmeasurable stretches of time, the region becomes indistinguishable from any other. The scar heals, not completely erased, but diluted into the fabric of the universe. And yet, something deeper may remain. Because at the scale of that final moment, where energies were highest and distances smallest, the usual distinction between spacetime and quantum information may break down. The scar may not just be geometric, it may carry information. Not in a structured, readable form, not as a message, but as a subtle imprint, a correlation in the underlying quantum state of the universe. Something that cannot be localized to a single point, but exists as part of the whole. In this view, the black hole does not simply disappear, it becomes distributed, its final state encoded not in a single object, but in the relationships between particles, fields, and spacetime itself. A memory without a location, a trace without a form. And this idea aligns with something we have been following all along. That information is not destroyed, it is transformed, hidden, spread out. The final burst carried much of it outward in radiation. But the act of that burst, the extreme conditions at the point of evaporation, may leave behind a deeper imprint. Something woven into the fabric of reality itself, not accessible, not observable in any practical sense, but present, a ghost of what once was. And as time continues, if time can still be meaningfully described, the energy from the explosion spreads further. The particles move outward, their wavelengths stretch, their intensity decreases. The universe, already empty, becomes even more uniform, even more quiet. The last dramatic event has passed. What remains is a slow return to stillness. No new structures form, no new interactions dominate. Only the long, gradual dilution of what has already occurred. The energy released in the final flash becomes part of the background, fainter, more diffuse, until it blends into the overall emptiness. And the location where the black hole once existed becomes just another point in space, no different from any other, no sign of the immense history that once unfolded there, no marker of the final burst, no indication that, for a brief moment, this region was one of the most extreme environments the universe could produce. All of that has been absorbed into the broader state of the cosmos. This is the nature of the end, not just for black holes, but for everything. Structures dissolve, energy spreads, differences fade. The universe moves toward uniformity, toward a state where nothing stands out, where nothing changes. And yet, within that uniformity, the past still exists. Not as distinct objects, not as visible events, but as subtle correlations, as patterns embedded in the fabric of reality. The black hole is gone, but the universe remembers, not in a way that can be accessed, not in a way that can be experienced, but in a way that satisfies the deepest rules of existence. Nothing is lost. Everything is accounted for, even if it can never be recovered. And as the last traces of the explosion fade, as the space-time scar softens, as the radiation becomes indistinguishable from the void, the universe continues. Quieter than ever, colder than ever, closer to stillness than at any point before. The end of the black hole is not a dramatic turning point for the cosmos as a whole. It is a step, another move toward equilibrium, another release of structure into simplicity. And in that simplicity, the stage is set for what comes next. Not creation, not renewal, but the long, silent era that follows when even the most powerful objects have disappeared. An era where the universe itself begins to approach its final state. A state of near-perfect darkness, near-perfect stillness, a state where the echoes of everything that has ever happened continue to fade. And after the last flash has faded, after even the faintest echoes have stretched thin across the void, the universe enters something new. Not a sudden shift, not a dramatic transition, but a settling. A long, quiet settling into what remains when everything that could happen has already happened. There are no stars, no galaxies, no black holes, no engines left to generate structure or change. Only energy, diluted to its lowest possible forms. This is the beginning of a deeper silence. A silence not just of sound or motion, but of possibility. Because what defines this era is not merely emptiness. It is the absence of gradients. No hot regions, no cold regions, no concentrations of matter or energy that could drive processes forward. Everything is nearly the same, everywhere. And in that sameness, nothing happens. The universe has reached what is often called thermal equilibrium. But here, that phrase takes on its most extreme meaning. There is no useful energy left, no difference that can be harnessed, no imbalance to create motion, change, or life. Entropy has reached its peak, not in a dramatic explosion, but in a quiet leveling. Everything spread out, everything evened. The energy released from the final black hole, the last burst we followed, has now become part of this uniform background. Its intensity has faded beyond distinction. Its patterns have stretched beyond recognition. Its information remains, in principle, but so scrambled, so dispersed, that it no longer forms anything we could call structure. It is there, but inaccessible. The universe, once filled with complexity, now approaches simplicity. A simplicity that is not elegant, but empty. And yet, even here, something persists. Time. Or at least something we still call time. But it is no longer what it once was. There are no events to mark it. No cycles, no changes, no before and after in any meaningful sense. Time continues, but without narrative, without direction. It does not flow toward anything. It simply is, a parameter without consequence. If you could exist in this era, if existence were still possible, you would not experience time as passing. There would be no way to measure it, no way to feel it, only a continuous, unchanging present. And within that present, the universe stretches on. Vast beyond comprehension, empty beyond description. Occasionally, extremely rare fluctuations may occur. Quantum fluctuations, tiny, spontaneous variations in energy. But even these are fleeting. They do not build, they do not accumulate, they appear and vanish, leaving no lasting trace. The conditions required for something larger, something stable to form, are no longer present. The universe has lost its ability to create. It can only persist. And yet, even in this near-perfect stillness, the laws of physics continue to exist. The underlying structure of reality remains. Fields, possibilities. The framework within which everything once happened is still there. It has simply reached a state where nothing significant occurs. A kind of cosmic exhaustion. All processes completed, all energy distributed, nothing left to do. This is sometimes called the heat death of the universe. Not a violent end, but a quiet one. A fading into uniformity. And it is here, only here, that we can fully understand the significance of what came before. The black holes, once the last structures standing, have now vanished. Their disappearance marks the final removal of complexity, the last sources of significant energy release, the last engines of transformation, gone. What remains is a universe that has reached its final configuration. Stable, unchanging, empty. And yet, even in this emptiness, the memory of everything that has ever happened is still encoded. Not in objects, not in structures, but in the exact arrangement of energy and fields. Every particle emitted, every fluctuation that occurred, all part of a vast, intricate pattern. Too diffuse to recognize, too uniform to interpret, but real. The universe, in this state, is like a completed equation. All variables resolved, all dynamics settled, nothing left to evolve, and still, it continues. Not because something drives it forward, but because there is no mechanism to stop it. Time, empty as it is, persists. Space, vast and uniform, remains, and the laws that govern them hold. This is not an end in the way we usually imagine. There is no final moment, no closing event, just an endless continuation of sameness, an eternity of stillness. And in that stillness, the universe becomes something almost impossible to grasp. A place where everything that once mattered, everything that once changed, everything that once existed as structure has dissolved into a quiet, uniform field. No light, no darkness in contrast, only the absence of difference. And yet, even here, a question remains. Is this truly the final state, or is there something beyond even this? Because the universe, in its long history, has shown a capacity for transformation, for emergence, for turning simplicity into complexity, and complexity back into simplicity. So perhaps, even in this deepest silence, there is still something waiting. Not in the form of structure, not in the form of energy gradients, but in the fundamental nature of reality itself. A possibility, a seed, hidden beneath the stillness, waiting for conditions we do not yet understand. And if such a possibility exists, then this quiet, endless era may not be the final chapter, but the pause before something else, something unimaginable, something that begins, not with light, but with nothing. And so the silence settles in completely. Not the kind of silence that follows a storm, not the quiet after something has ended, but a silence that has no contrast, because there is nothing left to compare it to. This is the era that remains when even the last black hole has vanished. The universe has crossed a threshold. There are no more dramatic events waiting, no hidden reservoirs of energy, no structures left to collapse or ignite. Everything that could unfold has already unfolded, and what remains is a vast uniform expanse, cold, still, endless. This is sometimes called the dark era. But even that name feels too expressive, because darkness suggests the absence of light relative to something brighter. Here, there is no reference point, no light, no shadow, only a uniform state that stretches without interruption. The energy that once fueled stars, powered galaxies, and drove the evaporation of black holes has been diluted beyond usefulness. It still exists, but in forms so spread out, so evenly distributed, that it can no longer do anything. No gradients, no differences, no motion driven by imbalance. The universe has reached maximum entropy, not as a catastrophe, but as a quiet conclusion. If one could somehow observe this era, not from within, but from some impossible external vantage point, it would appear unchanged. No flicker, no variation, an eternal still frame. And yet, within that stillness, the laws of physics continue to operate. Quantum fields still exist, fluctuations still occur, but they are small, isolated. They do not build into anything larger. Imagine a surface of perfectly calm water. Occasionally, a tiny ripple appears, but before it can grow, before it can interact with anything else, it fades, leaving the surface unchanged. That is the nature of activity in this era. Brief, self-contained, ultimately irrelevant to the larger state. The universe has lost its ability to amplify change. Everything that arises dissipates. Nothing accumulates. Nothing evolves. And yet, this is not a void in the sense of absolute nothingness. The framework of reality is still present. Space still exists. Time still extends. Fields still permeate everything. It is a full universe, but one without structure, without story, without direction. And in this state, the concept of future begins to lose meaning, because nothing new is expected to happen. No new events, no new transformations, just continuation, endless continuation. The difference between one moment and the next becomes indistinguishable. Time, once defined by change, now has no markers, no milestones. It stretches on, empty of events. And yet, even in this final equilibrium, there is something almost poetic, because everything that ever existed is still, in principle, present, not as objects, not as recognizable forms, but as information, encoded in the exact state of the universe. Every interaction that ever occurred, every particle that ever moved, all of it has contributed to this final arrangement, a configuration of unimaginable complexity that appears from the outside perfectly simple, uniform, featureless. But beneath that simplicity lies a history, not accessible, not recoverable, but real. The universe has not forgotten. It has only compressed its memory beyond recognition. And this leads to a strange realization. Even at the end of everything, nothing has truly been erased. It has only been transformed into a form that can no longer be used, no longer be experienced, no longer be known. And so, the dark era is not just the absence of activity, it is the culmination of all activity, a final state where every process has reached completion, every possibility exhausted, every difference resolved. And in that sense, it is not just an ending, it is a fulfillment. The universe has done everything it could do, it has explored every path available to it. And now, it rests. But even in this rest, there remains a question, because the laws of quantum physics suggest that absolute stillness may never be perfect. Even in equilibrium, there can be fluctuations, rare, unpredictable, but possible, tiny deviations from uniformity. Most of these are insignificant. They appear and vanish without consequence. But given enough time, vast beyond comprehension, larger fluctuations might occur. Events so unlikely that they would almost never happen. And yet, in an eternal timeline, almost never is not the same as never. This introduces a subtle uncertainty into the final state, a possibility that even in this deepest silence something could emerge, not through gradual evolution, not through accumulation, but through chance, a spontaneous reconfiguration, a fluctuation large enough to momentarily break the uniformity, to create structure, to create difference, to create something. These possibilities are extraordinarily remote, so unlikely that they challenge our ability to even think about them. But they are not forbidden. And that means the dark era, while stable, may not be absolutely final. It is the closest the universe can come to an ending, without truly reaching one. Because as long as the laws of physics allow for even the smallest fluctuation, there remains a door. Closed almost completely, but not entirely. And beyond that door, something may still wait. Not in the form of stars or galaxies, not in the form of black holes, but in a way that belongs to a universe that has already ended once, a universe that has gone silent, and yet is not entirely finished. And even in that near-perfect stillness, something lingers, not as a structure, not as a force, but as a faint presence, a residue. Because the radiation released from the final black hole, the last great burst of energy, did not simply vanish, it spread, outward, across distances so vast they defy meaning. And as it spread, it thinned, its intensity diminished, its wavelengths stretched. Its once brilliant signature softened into something almost indistinguishable from the background of the universe itself. But almost is not the same as completely, because embedded within that fading radiation, there are patterns, tiny correlations, subtle relationships between particles that were born together in that final moment. These patterns are incredibly fragile, not in the sense that they can be destroyed, because information, as we have followed, is preserved, but in the sense that they are nearly impossible to detect. They are diluted, scattered across unimaginable expanses, and yet they remain, like echoes, not echoes of sound, but echoes of structure, of history. If there were a way to gather all of that radiation again, every photon, every particle emitted in the final flash, and analyze their relationships, it might reveal something extraordinary. A map, not of space, not of time, but of what once existed. The stars that fell in, the matter that was consumed. The entire story of the black hole, encoded in a language so complex that it borders on the unknowable. But there is no one left to gather it. No instruments, no observers. The radiation travels freely, its patterns stretching thinner with every passing moment. And as the universe continues toward uniformity, these patterns become increasingly subtle, not erased, but hidden within the sameness. This is what we might call the ghost of the black hole, not an object, not a place, but a distributed presence, something that exists everywhere and nowhere, carried by particles that no longer interact in meaningful ways, a memory that cannot be accessed, and yet it is real. Because the laws of physics do not allow for its destruction, only its transformation. In this sense, the black hole has not completely disappeared. It is dissolved, its identity spread across the universe, its history encoded in the faintest variations of an otherwise uniform field. And these variations are so small, so evenly distributed, that they no longer create structure. They no longer influence events, but they exist as part of the total state of reality. If you could freeze the universe in this era, capture its exact configuration, you would find within it the complete imprint of everything that has ever happened. not as distinct records, not as readable information, but as a vast interconnected web of correlations. Every particle connected in subtle ways to every other. A final state that contains all past states, compressed into a form that appears simple. This is the paradox of the end. Maximum entropy, maximum disorder, and yet maximum information, because nothing has been removed, only rearranged, and in that rearrangement, the ghosts of the past remain. The ghost of the last black hole is only one of them. There are ghosts of stars, ghosts of galaxies, ghosts of everything that once gave the universe its richness. All present, all hidden, all woven into the quiet fabric of this final era. And yet, these ghosts do not act. They do not influence the future, because there is no mechanism left to bring them forward. No gradients, no interactions strong enough to reveal them. They are memories without expression, stories without voices. And as time continues, empty, unmarked, directionless, the distinction between these ghosts and the background fades even further. Not because the information is lost, but because the context needed to interpret it is gone. Without structure, without observers, without processes, information becomes indistinguishable from randomness. The universe still contains everything, but nothing can be done with it. This is the ultimate stillness. Not just the absence of motion, but the absence of meaning. And yet, even here, there is a kind of quiet beauty, because this state is not chaotic. It is not broken. It is complete. Every process has run its course. Every transformation has reached its conclusion. The universe has become a perfect record of itself, not in a form that can be read, but in a form that satisfies every law it has ever followed. And within that perfection, the ghost of the black hole drifts on. Not as a shadow, not as a remnant, but as part of the whole, indistinguishable and eternal. Until, perhaps, something disturbs the stillness. Something so unlikely, so rare, that it almost does not belong in the same story. A fluctuation, a deviation from uniformity. A moment where the perfect balance is briefly broken. And in that moment, the ghosts may shift. Not enough to become visible, not enough to form structure, but enough to remind us that even at the end of everything, the universe is never entirely silent. And as those faint ghosts continue to drift, even they begin to lose their distinction, not because they disappear, but because the universe around them becomes perfectly indifferent. The tiny correlations that once carried the memory of stars, of matter, of black holes are still there. But there is no longer anything to contrast them against, no structure to highlight them, no interaction to reveal them. They exist, but they do not matter. This is the final simplification, not just of objects, not just of energy, but of meaning itself. Because meaning in any physical sense depends on differences, on patterns that stand out, on relationships that can be traced. But here, in this state of near-perfect equilibrium, everything has become the same. Not identical in the microscopic sense. There are still fluctuations, still quantum variations, but identical in the only way that matters. There is no usable distinction, no feature that can influence anything else. The universe has reached what might be called absolute neutrality, a condition where every process has balanced out, every imbalance resolved, every potential exhausted. And in that neutrality, the number that describes change becomes zero. Not literally zero in every equation, but effectively, because nothing evolves, nothing transforms, nothing happens. If one could write the story of the universe in terms of motion, interaction, and change, that story has reached its final line. And after that line, there is no continuation, only repetition, not of events, but of sameness. Every moment is indistinguishable from the one before it. Time no longer adds anything. It does not reveal. It does not create. It simply extends. This is what it means for the universe to approach zero, not as a disappearance of existence, but as a disappearance of difference, a flattening. Everything reduced to its simplest, most uniform state. In this sense, the universe has returned to something resembling its beginning. Not in structure, not in energy, but in simplicity. At the very beginning, there was a kind of uniformity, a dense, hot state where distinctions had not yet formed. And now, at the end, there is another kind of uniformity, cold, empty, a state where distinctions have dissolved. The two are not the same, but they share a common feature, the absence of complexity. And in that absence, the universe becomes almost featureless, A vast, silent expanse where nothing stands out. Nothing calls attention to itself. Nothing changes. Even the faint ghosts we followed, the residual patterns of radiation, the encoded traces of everything that once existed become irrelevant, not gone, but indistinguishable from the whole. This is the final disappearance. Not of matter, not of energy, but of identity. Everything that once had a name, a structure, a story, has merged into the background. There are no longer objects, no longer events, only a continuous state. If we try to describe it, we are forced to use words that once had meaning, space, time, energy, but those words begin to lose their usefulness here, because they were built to describe change, and change is gone. What remains is a kind of mathematical stillness, a universe that continues to exist but no longer does anything. And yet, even in this absolute neutrality, something curious remains. The laws, the underlying rules that shaped everything from the first moments to the last. They have not disappeared. They still define what is possible, even if nothing is happening, even if nothing seems capable of happening. The framework is still there, and that means zero is not nothing. It is a state, a condition, a configuration of reality where all variables have settled. All processes have ended, but the system itself remains, waiting, not for anything in particular, not for a guaranteed next step, but simply because it cannot cease to exist. And this introduces a subtle tension, because as long as the laws remain, possibility remains, not likely, not imminent, but present. Even in a universe that has reached perfect equilibrium, quantum mechanics allows for fluctuations. Tiny deviations from uniformity. Most of them vanish instantly, but in principle, larger ones could occur, events so improbable that they defy intuition. But given an unbounded span of time, even the improbable becomes possible. This does not mean the universe will suddenly return to activity. It does not mean structure will reappear in any familiar way, but it means that absolute stillness may never be truly final. Zero may not be the end. It may be a pause. An infinite pause, but still a pause. And within that pause, the faintest potential remains. Not enough to restore what was lost, not enough to recreate the richness of the past, but enough to prevent the universe from becoming truly nothing. Because nothing, in the absolute sense, would require even the laws to vanish. And they have not. They remain, silent, unexpressed, but present. And so, the universe rests at zero, balanced, complete, empty of change, but not empty of existence. A final state that is both an ending and the quietest form of continuation imaginable. And in that vast, unmoving stillness, a question begins to form. Not from within the universe. There is nothing left inside to ask, but from the nature of the laws themselves. Because even in perfect equilibrium, even when everything has settled into this near-zero state, the rules that govern reality still allow for something unusual. Reversal. Not in the sense of turning back time in a simple way, not as a rewinding of events, but as a transformation of direction. A possibility that what once collapsed inward could, under the right conditions, expand outward. This idea is subtle, speculative, but it emerges naturally when we consider the full life cycle of black holes. Because throughout their existence, black holes have been defined by one action. They take in. Matter falls inward. Light is trapped. Information is hidden behind a boundary. Everything moves toward the center. But what if, at the deepest level, this is only half of a larger process? What if there exists a complementary behavior? A reversal, a structure where instead of absorbing, something releases, where instead of pulling inward, it pushes outward. This is the concept often imagined as a white hole, not observed, not confirmed, but allowed, in principle, by the equations that describe spacetime. A white hole would be the mirror image of a black hole. Nothing could enter it. Everything would emerge from it. Matter, energy, perhaps even information, expelled outward. A source rather than a sink. At first glance, this seems like a mathematical curiosity, a symmetry that exists in theory, but not in reality. But in the context of everything we have followed, the evaporation, the preservation of information, the final burst, it begins to take on a different role. Because when a black hole reaches its end, it does not simply vanish into nothing. It releases everything it has. In a final flash, a moment where all remaining energy escapes. And in that sense, the final stage of a black hole already resembles something like a white hole. A brief, intense phase of outward flow. But what if that moment is not just a release, but a transition? What if, at the smallest scales, where our current understanding breaks down, the end of a black hole does not lead to emptiness, but to a reversal of structure? Instead of a singularity hidden behind a horizon, a new kind of boundary. Instead of inward collapse, outward emergence. This does not mean that the black hole simply flips inside out in a dramatic, visible way. The process would be far more subtle, hidden within the quantum nature of spacetime, perhaps occurring at scales so small, so brief that it cannot be directly observed. But its consequences could be profound. Because if even a fragment of that transition persists, it could act as a seed, a starting point. Not in the empty, uniform universe we have been describing, but in a different context, a different region of spacetime. Some ideas suggest that such a transition might not occur within our observable universe at all. Instead, the final state of a black hole could connect to something beyond it, a new region, a new expansion, a new beginning. In this view, the end of a black hole is not just an ending, it is a bridge between one phase of the universe and another. The information that was compressed, stored, and then released could play a role in shaping what comes next. Not as a direct continuation, not as a simple rebirth, but as an influence, a contribution to a new configuration of reality. This idea is deeply speculative. It stretches our current theories, but it arises from a simple question. If the laws of physics allow for symmetry, if they allow for processes that can run in opposite directions, then why should collapse be the only story? Why should inward motion be final? Perhaps it is not. Perhaps it is only one half of a cycle. And if that is true, then the final flash of a black hole, the moment we followed as its last act, may not be the end of its story. It may be the beginning of something else. Not in the same place, not in the same form, but in a way that is connected at the deepest level, a transformation rather than a disappearance. And in the silent universe we have reached, the dark era, the state of near zero, this possibility does not manifest in any obvious way. There are no structures left to evolve, no energy gradients to amplify change. But the laws still hold, and within those laws, the possibility remains. Hidden, dormant, a potential that does not need activity to exist. Only the framework that allows it. And so, even in this final stillness, there is a subtle hint that the story may not be completely finished. Not in any immediate sense. Not in any way that restores what was lost, but in a deeper, more abstract sense. A suggestion that endings may contain the seeds of beginnings, that collapse may lead in some form to expansion, that the universe, even when it appears to have reached zero, may still hold within it the possibility of something more. And that possibility, however faint, however remote, keeps the story open. Not active, not unfolding, but not entirely closed. And if that possibility is real, then even this perfect stillness is not the full story. Because a universe that has reached equilibrium is not the same as a universe that cannot change. It is only a universe where change has become unimaginably unlikely, and unlikely, given enough time, begins to soften. Not into certainty, but into inevitability. Somewhere within the vast, uniform field that remains, a fluctuation may grow. Not the small, last fleeting ripples that appear and vanish without consequence, but something larger. A deviation that, by sheer chance, gathers enough structure to persist. At first, it would be indistinguishable, a slight imbalance, a tiny concentration of energy. But unlike all the others, it does not immediately dissolve. It lingers. And because it lingers, it begins to influence its surroundings. Not strongly, not dramatically, but enough. Enough to prevent perfect equilibrium from reasserting itself instantly. This is the beginning of something rare. Not a return to the universe as it once was, but a departure from complete stillness, a crack in the uniformity. And within that crack, processes can begin again, very slowly, very subtly. Energy gradients, however small, allow for motion. Motion allows for interaction. Interaction allows for structure. At first, these structures would be fragile, barely stable. But given enough time, time that stretches beyond any meaningful measure, they could grow. Not by design, not by direction, but by chance, guided only by the underlying laws that have never disappeared. And this is where the idea of cycles begins to emerge. Not cycles in the sense of repetition, Not a simple return to what once existed, but cycles in the deeper sense. A universe that moves from complexity to simplicity, and then, through rare fluctuations, from simplicity back toward complexity again. Not identical, not predictable, but connected. In this view, the end of the black hole, the final flash, the release of energy, the spreading of information, does not mark a final conclusion. It contributes to the total state from which new possibilities can arise. The radiation, the correlations, the subtle imprints left in spacetime all become part of the conditions that define what fluctuations are possible. They do not directly cause new structures, but they shape the landscape in which those structures might emerge. And so, the universe does not simply end. It transforms into a state where beginnings are no longer driven by grand events, but by the rarest of chances. A spontaneous reordering, a moment where the uniform field becomes uneven. And once unevenness exists, even in the smallest amount, the door to change opens again. This does not guarantee a new cosmos. It does not ensure the formation of stars, galaxies, or black holes, but it allows for the possibility. And in a universe where time has no end, possibility is enough. Because given infinite duration, even the most improbable events can occur. Not frequently, not regularly, but eventually. This is the deepest shift in perspective. The realization that the universe does not need to restart in a dramatic way. It does not need a new explosion, a new singular beginning. All it requires is a departure from perfect equilibrium. And that departure, however small, can grow. Not because it is driven forward, but because the laws of physics still permit it. And if such a growth occurs, if a fluctuation becomes large enough, stable enough, structured enough, it could evolve into something recognizable, not identical to the universe that came before, but a new configuration, a new expression of the same underlying rules. In that sense, the end of everything we have followed, the black holes, the stars, the galaxies, is not erased. It is incorporated. Its information, though scrambled and dispersed, becomes part of the foundation, a hidden influence, a silent contributor to whatever might come next. And so, the idea of an eternal loop begins to take shape. Not a loop of exact repetition, not a cycle that returns to its starting point, but a loop of possibility, an endless sequence of endings and beginnings, where each phase gives rise to the conditions for the next, where collapse leads to stillness, and stillness, given enough time, allows for emergence. And emergence, if it grows, can lead once again to complexity, to stars, to galaxies, to black holes, and perhaps to their eventual end. This does not have to happen. It is not guaranteed, but it is allowed. And in a universe without a final boundary in time, what is allowed can eventually occur. This is the quiet persistence of existence, not driven by purpose, not guided by intention, but sustained by the simple fact that the laws of reality do not forbid continuation. And so even in the deepest silence, even after the last black hole has vanished, even when the universe appears to have reached zero, the story is not sealed. It is only waiting. Not for something certain, not for something imminent, but for something possible. And that possibility, however faint, is enough to keep the universe from ever being truly finished. And so we arrive at the quiet edge of everything. Not an edge you can touch, not a boundary you can cross, but a moment of understanding. The black hole, once the most relentless force in the universe, the devourer of stars, the keeper of secrets, has lived its entire life. It has grown, consumed, held, and then slowly, impossibly slowly, it has let go. Atom by atom, photon by photon, until there was nothing left to hold, and in its final breath, it did not vanish silently. It spoke, in light, in energy, in a burst that carried the last memory of everything it had ever touched. And then it was gone. Not hidden, not waiting in the dark. Gone. Its story no longer contained within a single place, but spread across the entire universe. A transformation from something singular into something infinite. And as we followed that journey, through the fading glow, through the trembling of gravity, through the final flash, we arrived in a universe that feels almost impossible to imagine. A universe without stars, without light, without change. A universe that has reached its quietest state, and yet not a universe that has ended. Because even here, in the deepest silence, something remains. Not structure, not motion, but possibility. A faint, almost invisible thread that runs through everything. The idea that what has ended does not forbid what could begin. That even when everything has flattened into stillness, the laws themselves remain, waiting. And perhaps that is the most unexpected truth of all. Not that black holes die, not that the universe grows cold, but that endings, no matter how absolute they seem, are never completely final. They are transitions, moments where one story dissolves and the conditions for another quietly take shape. You may never see that next story. No one may. It may take spans of time so vast they erase all meaning from the word time itself, or it may never happen at all. But the possibility exists, and in a universe built on possibility, that is enough. So when we look back at stars burning, at galaxies spinning, at black holes consuming everything in their reach, it is easy to see only power, only dominance, only permanence. But the truth is quieter than that. Everything changes. Everything yields. Even the most unstoppable forces fade. And in that fading, there is something strangely beautiful, because it reminds us that existence is not about holding on forever. It is about unfolding, about becoming, and then becoming something else. The black hole does not lose its story. It releases it into a universe that, even in silence, still holds the memory of everything that came before. And maybe in some distant, unimaginable future, those memories, scattered, hidden, almost erased, become the seeds of something new, a new structure, a new light, a new beginning. Or maybe they simply remain as they are, a perfect silent record. And that too is enough, because not every story needs to restart to have meaning. Some stories are complete, precisely because they end. And this one, this journey from darkness to light, from consumption to release, from structure to stillness, is one of them. A story written across the entire lifespan of the universe, from its most violent beginnings to its quietest possible end. And now it rests. Not broken, not lost, but finished. And maybe, as you sit here, listening in the quiet of your own moment, there is something comforting in that. The idea that even the largest, most overwhelming forces in existence follow the same simple truth. They rise, they change, they fade. Just like everything else. Just like us. So tonight, as you let your thoughts drift, imagine that distant future, a universe completely still, and somewhere within it, the faintest echo of everything that has ever been. Not calling out, not demanding to be heard, just existing, quietly, endlessly. And in that quiet, there is peace. If this journey helped you slow down, if it gave your mind a place to wander and your thoughts a place to rest, then take a moment, gently tap the like button, subscribe to the channel, so you don't miss the next story that carries you into the unknown. Share this with someone who might need a quiet escape tonight. And if you feel like it, leave a comment below. Tell me what part of the universe you'd like to explore next. Until then, rest easy. The universe may be vast, but for now, all is calm.